Bubble warp shocking. New evidence found. Is time travel possible? The groundbreaking James Webb Space Telescope is poised to revolutionize our understanding of time travel. The concept of warp bubbles and time manipulation has long fascinated humanity. Scientists and physicists have dedicated decades to unraveling the potential for human time travel. While once deemed impossible, recent advancements and research have upended this belief. Initially, Russian astrophysicist Dmitry Novikov challenged time travel through his self-consistency theory. He posited that any event leading to paradoxes or alterations in the past would have a zero probability of occurrence. This theory aimed to preclude time paradoxes. Despite this theory, scientists persevered in their pursuit of time travel. Their dedication paid off when researchers responsible for the James Webb Telescope's discovery introduced the groundbreaking concept of a warp bubble, making time travel theoretically feasible. If you're intrigued by news about the James Webb Space Telescope, NASA updates, and space news, remember to like this video and hit the subscribe button. But what precisely is time travel? How does supporting theories contribute to this notion, and how might the warp bubble play a pivotal role in its realization? Regarding the notion of time travel, it's essential to distinguish fiction from reality. For many enthusiasts of science fiction, time travel conjures images of journeying to the past or encountering one's future self. However, genuine time travel doesn't involve stepping into a time machine and selecting a different era. Instead, the real concept is founded on rational principles, and recent research has enhanced its potential feasibility. The notion of traveling through time as depicted in fiction was debunked years ago by the renowned Stephen Hawking. In his 1994 work, Black Holes and Baby Universes, Hawking asserted the implausibility of time travel, reasoning that if it were possible, individuals from the future would have already visited us. Nonetheless, fictional portrayals of time travel have permeated popular culture, leading to misconceptions. Countless movies have perpetuated unrealistic scenarios wherein protagonists navigate different eras to save the world. This has engendered confusion about the actual concept. Actual scientific time travel traces back to Einstein's 1905 relativity theory, which introduced the idea of time dilation. According to this theory, time is an illusion that varies depending on the observer. Einstein proposed that time halts when a body reaches light speed. This concept implies that an observer moving at light speed would outpace time itself, causing relative time on Earth to slow. To test Einstein's theory, NASA executed a remarkable experiment in 2015 using identical twin brothers, Mark Kelly on Earth and Scott Kelly in space. Scott traveled at high speeds for a year while Mark remained on Earth. Although the experiment was successful, the results were inconclusive due to the spacecraft's speed not approaching that of light. In essence, true time travel doesn't entail visiting different eras, but rather involves achieving speeds faster than time itself. Nevertheless, surpassing the speed of light, a crucial factor for time travel, remains an insurmountable challenge. The fastest spacecraft reached a speed of 163 kilometers per second, nowhere near the speed of light, which is 299,792 kilometers per second. These insights have dashed hopes of traveling between stars, as even the nearest star, Proxima Centauri, is 4.2 light-years away. This means that even at light speed, it would take 4 years to reach it. The advent of the James Webb Telescope has added a layer of complexity to the time travel discussion. The telescope's capacity to observe distant objects means we're effectively seeing light from the past. Einstein's general relativity theory has spurred further research despite the initial doubts about space travel, later revolutionizing time travel research. His theory of general relativity. This theory proposed that what we perceive as gravity arises from space-time curvature. It contrasts with Newton's gravity concept. According to Einstein, the universe is a stretched space-time fabric, and planets rest on it. The mass of planets bends this fabric, introducing a fresh gravity concept. It's suggested that more mass attracts more entities. Imagine a 7-kilogram ball on a trampoline center. Smaller 3 or 4 kilogram balls gravitate toward the pit formed by the large ball. Similarly, the Sun, large ball, creates an energy pit drawing planets. smaller balls. Scientists speculated that with a high-energy mass, they could impact spacetime's fabric, forming a warp bubble. Both theories clarified two things: to reach Proxima Centauri, a craft exceeding light speed and having significant mass was necessary. NASA researchers pursued ways to achieve spacetime travel. In 2021, under DARPA funding, Harold White inadvertently discovered a warp bubble drive enabling space travel. This drive stemmed from the concept of warp drive in Star Trek. Miguel Alcubierre proposed a negative energy technology based on Einstein's theory, suggesting a warp bubble could contract spacetime in front and expand it behind, reducing travel distance. However, creating a warp bubble was energy-intensive until White's breakthrough. Eric Lentz later proposed a soliton-shaped warp bubble requiring less energy. In July 2021, Eagle Labs and NASA published a paper discussing negative energy density around the Casimir cavity, potentially providing the energy needed. White's team explored energy distribution across wavelengths in our nano experiment, theoretically facilitating faster-than-light warp drive. NASA's challenge lies in navigating the unknown territory warp drives explore. High speeds could pose a danger to the spacecraft and passengers, requiring robust shields. Regardless, NASA is committed to realizing warp drive, enabling travel over vast distances quickly. Engineers and researchers are dedicated to making this concept a reality. Share your thoughts on warp drives and the possibility of reaching Alpha Centauri. Stay updated on James Webb Space Telescope, NASA, and space news by subscribing.